Objectives. Describe the role of dynamic routing protocols and place these protocols in the context of modern network design. Identify several ways to classify routing protocols. Describe how metrics are used by routing protocols and identify the metric types used by dynamic routing protocols. Determine the administrative distance of a route and describe its importance in the routing process. Identify the different elements of the routing table. What are the functions of dynamic routing protocols? It's dynamically shared between routers. It is automatically updated when topology is changed, and it's determined best path for a destination. What is the purpose of dynamic routing protocols? Discover remote network, maintaining up-to-date information, choosing best path for destination network, and ability to find a new path if the current path is not available. Components of a routing protocol. In the case of routing protocols, algorithms are used for facilitating routing information and best path destination. Routing protocol messages. There are messages for discovering neighbors and exchange of routing information. Advantages of static routing. It can back up multiple interfaces or networks on a router. Easy to configure, no extra resources are needed, and more secure. Disadvantages of static routing. Network exchange required manual reconfiguration and does not scale well in large topologies.
Types of routing protocols. Interior Gateway Protocols or IGP, Exterior Gateway Protocols or EGP. Interior Gateway Protocols or IGP used for routing inside an autonomous system and used to route within the individual networks themselves. For example, Open Shortest Path First or OSPF, Routing Information Protocol or RIP, and Enhanced Interior Gateway Routing Protocol or EIGRP. Exterior Routing Protocols or EGP used for routing between autonomous systems. For example, BGP-B4. Exterior Gateway Protocols or IGP, comparison of distance vector and link state routing protocols. The distance vector routes are advertised as vectors of distance and direction. Incomplete view of network topology. Generally periodic updates. The link state complete view of network topology as created. Updates are not periodic. Classful routing protocols versus classless routing protocols. Classful routing protocols do not send subnet mask in routing updates, while classless routing protocols do send subnet mask in routing updates.
Now, let's proceed to the last classification for routing protocols. So the last classification for routing protocol is the convergence. So what is convergence, by the way? So convergence is defined as when all router routing tables are at the state of consistency. So here is an example or a diagram for a convergence in routing protocol. So as you can see, there are three routers, and in the three routers, we can clearly say that the routers in the routing table are transmitting or in a continuous and flawless transmission of packets. So that's what you call as convergence. We're in a state of consistency. Let's proceed to routing protocol metrics. So first and foremost, what is metric? Metric is the value used by a routing protocol to determine which routes are better than the others. So which route is better? Yeah. So this is the value wherein the routers will use this values to like compare and determine which routes is better than the others for a faster and a more safe transmission of data or packets. In a routing protocol metrics, what metrics are used in IP routing protocols? So first is the bandwidth, second is the costs, third is the delay, fourth is the hoop count, and fifth is the load, and lastly, reliability. So these are the metric being used in an IP routing protocol. So the routing protocol metrics, the metric field in the routing table, metric used for each routing protocol, the RIP or hoop count, the IGRP and EIGRP, bandwidth used by default, delay used by default, and lastly, load and reliability. The next is the ISIS and OSPF, cost, bandwidth, wherein managed by the Cisco's implementation. And now let's proceed to the routing protocols, the load balancing. So load balancing, what is load balancing by the way? So load balancing is the ability of a router to distribute packets among multiple same cost paths. So when we say load balancing, it is the ability of a router wherein the router will be the one to manage the packets among certain paths so that each path will receive an equal and same amount of packets from the others. So that's all.
Purpose of a metric. It's a calculated value used to determine the best path to a destination. Then, purpose of administrative distance is a numeric value that specifies the preference of particular route. Uh, then, identify the administrative distance in a routing table. It is the first number in the bracket in the routing table. They directly connected routes have a default administrative distance of 0. Static routes administrative distance of a static route has a default value of 1. And directly connected routes immediately appear in the routing table as soon as the interface is configured. Then routing protocols fulfill the following function. They dynamically shared information between routers and automatically update routing table when topology change, determine best path to a destination, and the routing protocols are grouped as either interior gateway protocols or exterior gateway protocols. The types of interior gateway protocols include classes routing protocol. These protocols include subnet mask in routing updates, and the one is classful routing protocols. These protocols do not include subnet mask in routing update. Metric are used by dynamic routing protocols to calculate the best path of destination, and administrative distance is an integer value that is used to indicate a router's trustworthiness. Components of routing table include route source, administrative distance, and metric.